The philosophy of mathematics is to find an elementary proof to every conjecture possible. An elementary proof is a simple way of proving something. For example, let us try to understand this with the example of prime numbers. Prime numbers are very notorious because it is very difficult to wrap them into functions and understand them. A prime number is a number, natural number, which has two divisors. The one is 1 and the other is that number itself. So 1 is not a prime number because although it has a divisor 1 and itself, but because 1 happens to equal to its divisor 1, it has only one divisor. So it's not a prime number. 2 is the only even prime number because every other even number will have the divisor itself and 1 in addition to 2 because it will be a multiple of 2. So 2 is only even prime number. So rest all of the prime numbers are odd. Now we know that, but we also know from Euclid's theorem that there are infinitely many primes in natural numbers. So what is the distribution of the prime number? When we give some of the examples of prime numbers, we intuitively understand the distribution is not equal, it's not equally spaced. So what it is? So two of the beautiful mathematicians gave us a conjecture. Conjecture is a final result of something without any proof. So they gave us that a function of a natural number is almost equal to that natural number divided by log of that natural number. And that function of that natural number is that distribution of the primes up to that number. And so we had the result, but it was very difficult to do. And almost after 100 years, two other beautiful mathematicians proved that conjecture. So it was fantastic, phenomenal. But for proving that conjecture, what they did was they used Riemann Zeta function, which consists of complex numbers. Complex numbers has real numbers and imaginary numbers. And an imaginary number has a component of square root of -1. So to prove something for natural numbers, prime in the natural numbers, we had to go through complex numbers and take use of the Riemann Zeta function is a very complex thing. And we did have the proof, but it was an elementary proof. It was very complex. So we were looking for an elementary proof in mathematics, and after 50 years, we did get another proof for this conjecture by two other beautiful mathematicians. And that's what we are looking for in mathematics. Yes, there are conjectures, yes, there are problems, and yes, there are difficult things to wrap around our heads. But we are not only looking for a solution, a proof, with using any means possible. Yes, that helps at the first step that this problem has a proof, yes or no. But we also looking forward to multiple proofs to find elementary proofs. Little less complicated, using less and less advanced things. That's it for today, guys. See you next time.